Jason here. It's been a while since I did a good in-depth video tutorial. I don't know how long ago it was I posted the CSL one, but I thought the Arbor is probably a good excuse to really dig in and go through some of the features. The full written manual is still in the works. The module itself does ship with one of these guys, which is a quick start guide. A lot of information in there, but there's still a lot of detail to be covered in the module setup itself. So get some popcorn. I think this is going to be quite a long one. There's a lot of ground to cover, so I'm just going to tap away at it and see where it leads. Hope you enjoy. Cheers. All right, let's dig into the ins and outs of the Arbor. I'm going to try and go as methodically as I can, but there's a lot of things to cover. So let's just start at the top. We have our main input, top left jack, input gain. This gain stage is based on the same circuit that I developed for the upcoming looper module. So it's analog limiting, so it means that even if you drive it really aggressively, it's never going to get the chance to digitally clip at the audio codec. It's always going to saturate analog first, and then you'll be capturing that. So you can use it as inbuilt overdrive, saturation, etc. Next we have wet dry mix. All the way wet, you'll have only granular playback. Dry, the signal pass through unaffected. Output attenuator over the two output jacks. So you can see we're listening to just a mono output at the moment, so that's coming from the top jack. With nothing patched out from the lower one, the signal actually normalizes and sums with the top one. So if there's granular playback, which would normally be dispersed between the two outputs, it will layer up and you'll get all grains from the top one. As soon as you patch a second jack out, you will have the grains distributed between the two. We'll listen in mono initially, and then I'll add in a second output as I get to more of the grain parameters and stuff. Okay, so if we come down to this section here, this is essentially the transport or playback control section, where the main scan pot that's scanning the playhead through the contents of the buffer. Buffers there are 6 of. So we've got alpha, beta, gamma, delta, epsilon, zeta. Each one of these buffers is 10 seconds long, can be recorded to independently, and all the audio can be played back simultaneously from any of these 6 buffers if you're sweeping through. You can see that each one has its own color scheme. This is largely aesthetic, but it does come in useful, especially when you've got CV control over the layer, which is accessed via the included expander. So you can visually see very quickly where audio is being pulled from, as well as keeping track of the actual layer LEDs there. So to start with, let's capture some audio into the buffer. We're listening to just the lower final output from CSL. It's a static pitch that's being controlled from the harmony manually here, and I have a little bit of modulation going into the wave folder that's coming from a self-patched oct. So just a little bit of movement there. So what I'll do, I will start capturing. You'll see a secondary LED, white LED moving along that is displaying the record position in the buffer. As it records in, I'm just going to play through a minor pentatonic scale into it. That way, when we come back to playing it granular, there's something more relatable that we can see the placement throughout the buffer. So here we go. To capture, I'm going to hit the capture button, and that will start recording. dry input signal and the granular playback. So I'll set this to fully wet. I can actually mute and remove the input signal at this point. And we can also see that the signal amplitude is displayed via the backlighting, so it lights up from left to right to indicate the audio amplitude. And the playhead moves along, showing us where we are exactly in the buffer. So for actual playback parameters, I'm going to jump to these 4 controls in the middle. So these control like 4 of the main parameters for the specifications of the actual grains. So first up, we've got intensity. You can see it's got the highest intensity when it's at the center 12 o'clock position. If I bring that down anti-clockwise, the grain count will reduce until they're not overlapping. There's just spacing between them, and you can see it's periodic grain firing. If I go on the opposite side, there's a little bit more random deviation to it, but there's also inclusion of some random amplitude difference between the grains. It just adds a bit more of a organic scattering to them. So 2 different flavors of how grains can be built up. What I'll do at this stage, actually, I'll plug in this second cable. I'll be fixing this in the audio edit for this video so that it's jumping from being just a single dual mono to left-right. Now we have grain distribution between the 2 outputs. So by default, this is hard pan. This is it's not directly alternating left right left right left right. It's coin toss logic where a grain's going to fall. Okay, I'll bring intensity down a bit, and now let's play with the length of the grain. So you can see the grain length is actually displayed by the playhead. So wherever I move that, I can actually see the region of audio that grains are being played from. So the duration range, it goes down from about 40 millisecond duration up to 3 seconds. Okay, what I'll do now, I'm going to jump back down to this section and show the spray control. If spray's all the way down, then all the grains are going to be firing from that precise location in the buffer. As soon as I start introducing spray, it's going to be deviating from that defined start point. So it means like in this instance where I've got a pentatonic scale played throughout the buffer, I can automatically have the grains scattering throughout the entire length. And also if I have the scan towards the end, as I bring up the spray, it will start pulling from previous content, so earlier on in the buffer. Okay, I'll set that to a point where we can hear a few different notes. So let's jump up to this control here. So far everything's been sort of nice and soft and smooth. So that's this control at 12 o'clock. That is a Gaussian curve for enveloping over the grains. If I turn it clockwise, we'll hear things start to get a bit more percussive. So this is a descending ramp envelope. If I go the opposite direction, we'll end up with essentially no enveloping. It's just a solid block. So however long the duration is, it could be firing a 3-second grain. It's just going to play a 3-second segment of the audio without any attenuation on the starter end. Okay, so if I bring intensity all the way down, a second way that I can fire grains is with this strike button. There's also a dedicated input jack, so this is for externally clocking grains. So this way I can have direct manual control over grain density in parallel to the internally clocked density. Grain count between the two, if they are only internally clocked with intensity, then this can be up to 24 grains simultaneously of up to 3-second duration. Externally clocked, that's a further 20. So when you've got external clocking as well as internal intensity, that's up to 44 grains that can be played simultaneously, polyphonically. Okay, the last section of this set of parameters is the grain direction. So I'll keep it on the ramp envelope because that'll be easiest to hear. Keep it internally triggered. If I bring the pot to the center, that's even 50-50 probability of grain direction. If it's hard left, then they'll always be playing in the forward direction. Hard right, and they'll always be playing in reverse. So for the ramp envelope shape, we can hear that reverse swell of it. Because this is just an oscillator tone captured in, we can't really tell the direction the audio is playing in, but if this was a more complex audio like a spoken word or something, then you'd hear snippets of audio that were being played backwards. So next up we have pitch control over the grain playback. The way that this differs from other granular engines, I think, when a grain fires, and if the pitch is changed, the pitch of the grain playing doesn't dynamically change. It only updates when a new grain fires. So it's almost as if there are multiple sample and holds on over all the parameters. So when a grain fires, it's playing back at the defined length with the defined windowing from the defined location, 50-50 chance potential of if it's forward or reverse at a defined pitch. So I think the best way to show this, I'll jump to a second buffer just so that we can always go back to this content. So let's not work destructively at the moment. I'll put the signal back in. What I'm going to do, I'm going to take out the wavefold modulation and then just capture in 10 seconds of me playing a static tone while bringing up the wavefold depth. I'll keep it at that tone, so we're just on the root of the previous pentatonic scale. So let me start capturing now. I'll keep it soft to begin with. Do my best to get a nice smooth sweep. That should do. Okay, so if I keep the spray all the way down, I'll set it back to Gaussian curve, random distribution. So now with playback, I effectively have a timbre control coming from the scan pot. So let's reduce intensity. I'm going to externally clock the grains. height up a bit. I'll set it to forward direction only, and the ramp enveloping. So now you can hear it's like multiple pitches playing on top of each other polyphonically, depending on how long a length I have. So now, as I adjust the pitch, a grain of fire, when the next grain plays, it's going to be playing with the new defined pitch. So this can mean that at longer lengths, the effect of the pitch control, it can seem a bit slow because its definition of a parameter for grains that then fire. But of course, if you have lower grain count, higher intensity, the overall effect is going to be much more immediate. But you don't have this sort of unnatural like glissando of individual notes. It's more of a polyphony-based method. So a real benefit to working in this manner is let's jump back to this harmony. I'll set it to quantizer mode, and I'm just going to quantize random CV from a sample and hold. I'll use the gate output from the harmony, so that'll be my clock source. And then pitch control via the volt per octave. So the pitch pot, that will give me 2 octaves up, 2 octaves down. There's a nice generous center, I guess dent, not a physical dent on the pot, but it's very easy to settle on the original playback pitch, which I find is always quite important, especially when you're working with capturing external audio in this manner. So now the grains are being triggered whenever a new note is quantized, and I'm going to define the pitch at volt per octave. Increase the range of it. So it's a way that I can build up polyphonic voicings with variable timbre depending on where I am in the buffer. I'll bring length down a bit. Now if I increase the spray, the placement the grains I'll be pulling from will be dispersed across the full buffer. Add a bit of variation to the direction. Soften the enveloping a little bit. Add in some extra grain playback. And of course I could immediately jump to the older buffer content. Depending on what note of the scale that I captured in previously, that's now my new fundamental essentially, so the pitch is being modulated of that. So it can really be used as a compositional tool harmonically in this way if you're sampling in constant toned buffer content. Okay, I'll remove that pitch control now. Let's look at the secondary pitch pot. Let's keep it internally triggered. So with the pot in the center, this pot does have a physical center detent, so it's very easy to find the off position. So this is almost like an attenuverter control-wise. Going anti-clockwise to the left is going to add random pitch deviation to the grain starting point. So it's essentially a built-in sample and hold that's summing with the defined frequency. So sometimes if you just want a little bit more fuzziness, you'll say this was maybe if it was like a sawtooth waves, you could get that really sort of nice, subtly detuned up to complete random chaos. Let's put some spring to get a bit more variation. Okay, now if I take it clockwise, this adds in essentially quantized pitch. So all the way up, and it's going to be jumping up an octave up or an octave below. And throughout that range, it's actually adding in a set of chromatic quantized voltages, but done in what we felt was a very musical way. So the first step up, this is going to be playing the original pitch, a minor second up, so a semitone up, and 2 semitones down. So minor second up, major second down. Next it'll flip, so it's giving me major second up, minor second down. So that's giving me a minor third up, major third down now. Major third up, minor third down. Skipped one. There we go, so that's perfect intervals. That will be a fourth up, fifth down. There's the tritone. Fifth up, fourth down, and so on. So major 6, minor 6, same for the sevenths, all the way up to the octave. So the octave is it's always a handy one, especially if you're working with multiple different notes. So this is back to the pentatonic scale source. Being octaves, it's always going to be on pitch. Increase the length, increase spray. And of course there's CV over all these parameters. You've got volt per octave over pitch. Intensity, length and scan, those have their CV on board the module directly. With the 2 HP expander that comes with, there's CV over everything essentially. So bipolar CV over the pitch deviation. So it means that if you have a more precise CV source, like a nice long fader, or using a Vinca, then you can get nice precise control over the intervals, or that could even be sequenced, so you could be sequencing through the different interval differences. What can be quite a nice way to do is if I use a longer patch cable for starters, just a DC voltage through like a switch, I could patch that into pitch deviation. So when it's off, we're at unisons. As soon as I turn it on, it's effectively jumping that all the way up to the octaves. Ways to quickly add in a nice degree of variation. Back to our second buffer, which is more timbre based. You'll also hear when a grain fires from a certain layer, especially when they're longer, like this is on the longer end, not quite 3 seconds, but those grains will complete in their entirety while more grains are coming from the currently selected buffer. Next up, I want to dig in a bit deeper on using multiple buffers and capturing audio to multiple buffers or layers. It's labeled as layers on the module because playing back grains, they layer up, but they are 6 individual audio buffers. So I might flip between the two terms when describing. So I'm going to simplify things a bit. Let me go back to an external audio input. Let's keep things mono for the time being, just so it's a bit easier to focus in. Okay, so my dry signal. Back to this. A bit of movement from the oct. I'm going to leave the alpha buffer as is, and I'll jump to beta as our first destination. So we can hear there's still the wavefold sweep captured in there. If I want to clear a buffer, I hold Shift and press the strike button. So you can see it's blinking yellow at the moment. That means there's something that can be undone, essentially, or deleted. So if I press it once, that removes all the audio from that buffer. If I capture something new in, let me go back to this. So that's some new content. If I power cycle the module, every time there's new content captured in from the capture button, then the module auto-saves, so all the audio is retained in the memory, so you can power off, power back on, and it will be exactly as it was when you left off. If you want to be more active in saving, then there are a few options. So at the moment, that's me captured in a little bit of that tone. If I jump that up an octave, jump up an octave and a fifth, and I'm going to capture that in now. Bring the spray down, length down, go fully wet. You hear that new take of that new pitch has overwritten that first layer of content. So if I do Shift capture, it's undone the last thing. So you've got one stage of undo if you're capturing new content over something. At the moment, that completely replaced the audio. If I use the dub control up the top, if I put it all the way up, then that's going to be 100% blend of the previous content with the new content. So if I now go back to dry, there's my new tone. If I capture a bit of that, go fully wet, I've now got the previous content with the new content layered on top. So I could press that again, and it's undone it. If I want to more actively save something to return to it, if I can hold Shift, capture, then press strike. So that blinking there, that showed that it's done an active memory dump. So if I delete, so because there was nothing to undo at that point, it's cleared the buffer. If I hold it again and press, it will reload that content. So it means that I could go to full destructive replacement with dub all the way down, capture silence over that because I had the input muted. I could undo that, but say I do this twice, so I'm back to my original sound, capturing silence over it. So I've now erased that first portion. If I capture again, I might destructively replace or erase more. If I do undo, I'm only doing that last step of undo that I did. But now if I delete, then reload, and back to the memory content that I actively saved. A bit of mental gymnastics remembering all the button combinations, but there are a lot of bases covered. You can actually also export audio to a built-in USB drive, which is accessible on the back. So it means that you can export any audio and it will render out at 48 kilohertz 24-bit wave files. Files can also be loaded in as well, but I'll come back to that in more detail as I go. Okay, so now back to capturing some content between multiple layers. I'm going to start by getting a few different tones. We've got modulation here. So I'm going to build up effectively a chord, but the chord tones spread across multiple buffers. So I'll start with a lower octave than was in the first of the pentatonic scale notes. So I'm going to capture this for the duration of beta. Now you'll see as the record head goes along, that's showing the full 10 seconds. One extra thing to note, after it's past the 10-second point, you saw the capture button was still lit to show it's recording for a couple of seconds beyond. That's more of a general overlap. So it does actually record an additional 2 seconds from the 10-second buffer. We realized that if we want to be playing through the full 10 seconds of a buffer, if you move the scan playhead all the way to the end, you'd be hitting a brick wall of silence. So there would be no content to play. So it meant that if the controls are going out to their extremities, then you would lose, you'd have audio dropouts. So with having the ability to capture that extra 2 seconds, it just keeps a little bit of a buffer. There's a little bit of extra audio content. So if you push out to the 10-second mark, there's still something there that it can play from. So you'll see if spray is brought up, then it's going to start pulling back from the very end. It means that there's that 2-second leniency, plus it will then start pulling from the rest of the content. Okay, so there we have playback. That's a nice low tone. I'm going to move to the next buffer, retune to perfect fifth, and I'll just capture that for the duration again. Next, I'll go up an octave and tune in a minor third. And maybe add in the fourth above, so we'll make this a minor 11th. So you can hear I'm still able to play from any of the audio from other buffers while stuff is capturing to a new one. So if I mute my input now, increase the length a bit. Just scanning through the different buffers and playing long grains pulled from that source audio. That's why we had a few more octaves. I had that CV still on from before, so that was pushing the octave jumps in. That back in, it's the same as if I'm turning this pot all the way up. So here I can build up a bed of these chord tones. And add in little grace notes from this original buffer, which is my pentatonic scale. Gauge this so I can have some octave jumps in between. So compositionally it can be very useful for creating drones for tonal ambient work. So the reason I'm doing this is so I can show the capabilities of locking a record destination, because at the moment whenever you move the layer control, we're choosing where we're hearing grains played from. Anytime I hit capture, it's going to start capturing to wherever it's currently set. So if that's for safety, let's just do a manual save of alpha so that I can return to it if I need. There's now nothing in my alpha layer, so I'm going to go back to some sample and hold random CV into the harmony. And maybe slow the rate down a bit. We've got, there we are. So that's a minor pentatonic defined in on the harmony. Now I can capture this in. Mute the input. It means these 4 layers from beta onwards are static chord tones, and then alpha has a lot more content going in because there's more notes that have been captured in across the buffer length. So say I want to keep capturing new material from that voice into alpha, but during that I want to have some control to be able to play grains from any of the other buffers. If I hold down shift and then turn the layer control, I can decouple the recording destination. So you see I turned it there, I've now turned alpha yellow. That means that any time I capture content, it's going to be recording it to that buffer. So at the moment, gamma is still selected, so that's what we're hearing from. The LED's pulsing, so that should show that it needs a movement pickup to lock to it again to then move the selected buffer for playback. This is a design choice just so that if you're wanting to actively change things, you might have more aggressive content saved to or recorded to other buffers, so you don't want it to immediately jump. You want to have a bit more control over that. So now I can be playing from any buffer I like. I recorded over alpha. We didn't hear that happening because we're only monitoring gamma. But now if I bring my input back in and start capturing, that's only ever going to be capturing to alpha. So fixed tone, I'll take the octave jumps off. Fixed chord tones, and then anytime I select alpha, I've got a lot more busyness going on. So I'll maybe slow this sample and hold down a bit and expand the range. So that anytime I'm capturing, there can be higher notes engaged. Modulation. I'll take LFO from an oct. I'll just attenuate that through a Vinca just so we've got a bit of range limitation. And I'll patch that into the layer CV. So you see we have some movement as the LFO swings through. Select a lower channel so we have slower movement. So the CV over layer, it's independent of the pot position. It actually sums with it and will give multiple turns round, so it means you can get more than 360 degrees of movement with the positive or negative CV. So now that's more automated for playback source, but at any time I can start capturing, and that's going to add more new content to alpha. Now if I want to recouple the playback and record destination, then I simply hold shift. If I turn it all the way to what would be omega, that's it now pre-paired. Okay, now to actually properly visit the omega control, I'll take CV over layer out. I'm going to bring spray all the way down. So I'm capturing from the actual precise location, it's not moving the granular playhead much. If I turn the layer control all the way to omega, it chains all the layers start to end in a row. So now as I sweep through scan, I'm sweeping through all 6 buffers one after the other. So of course I've got nothing in the last one there. So here's a quick example from random voltage from a sample and hold going into the scan CV input. So now we're actually getting playback from across all 5 of the filled buffers. Increasing the length, intensity, windowing. There's a lot of range of control. This is without any CV over any of the other primary parameters so far as well. Next up, I want to draw our attention back to the input stage of the arbor. This time with no modular signal going into the input. I'll come back to the onset detection section soon. But first we're going to look at this little hexagonal pattern of holes here. This is actually the arbor's own built-in internal condenser microphone. So behind that pattern of holes, there's a little electric capsule that's just constantly picking up ambient sound around the environment the module's in. Generally, if you have the input turned down, you're not going to hear that. Its signal normalizes to the onset input, which then further normalizes to the input. So if I bring up a mix of wet and dry, turn up the input gain, we'll hear some finger noise, but we should hear my voice just picked up ambiently from the module's own microphone. Probably not quite the quality of the main microphone I'm recording with, but definitely some interesting things that can be done with it. So let me just capture in some noises of your finger clicks, claps, scratches, and see what we get. Okay, I'll mute the input, go fully wet signal. And just scrubbing through alone, there's a lot of very interesting textural material we can play with. And then if I further modify grain length with a softer Gaussian curve, we'll get some reversals of the audio playback. Increase spray, I'll be able to set a start, the playhead position, and then it's going to be pulling from areas further on in the buffer. Of course, we can add in pitch deviation to this. Turn the top pitch control anti-clockwise. I'm going to get a random pitch deviation added to every single grain. Try adding some more stuff into the mix. I've got the dub position set to 12 o'clock, so that's going to be sort of half amplitude of the existing material in the buffer that will remain, and anything I capture in on top will be the sort of replacing it with a lower mix of the previous content. So let's try something new here. Input microphone would help. Starting to get some almost bell-like qualities of the detuned wine glass. If we bring the spray down lower, maybe a shorter length, higher intensity, you can get that sort of time-stretched response. Actually, one thing that can be done if we use like an envelope generator, I'll use the cease here with maximum attack length, linear response. I'll patch that into scan. So now, as soon as I trigger it, the playhead's going to be moving through the scanning through the buffer. So again, using CV can be quite a fun way to automate movement through all the audio content, or simply using LFOs to shift it through. I'll add one more layer of content. This is a good use for a pack of Biffaco knurlies. A bit more pitch deviation. now I'm going to bring the spray down to a fixed position, and I'm going to explore the grain length parameter a bit more than we did previously. So we know that that goes from sort of a 40 millisecond duration all the way up to 3-second grain segments. If I bring it down lower than the 40 milliseconds, we actually have a transition into a parallel synth engine. So there's actually a wavetable oscillator built in that is using the same buffer content as its source. So wherever we are, we can immediately jump down to single cycle waveform of the content. And this signal, of course, tracks volt per octave, which could then pitch control from a quantized sample and hold. So in this setting, the texture pot, it affects the harmonic makeup of the wavetable. It's largely dependent on what the content is of the buffer, of course, but it does give you a little degree of a timbre shift. Intensity, if I bring that all the way down, it will attenuate and mute the signal, the same way as if you're turning down the intensity of the grains. So it means you've got consistent silence between the two voice types. If I go back to a static pitch, if I increase spray, the rate of the intensity that would typically be triggering grains, this is actually moving the position of the buffer for generating a different waveform. I can use the built-in pitch quantization to generate their own melodic patterns or random pitch deviation. Especially using control voltage over these parameters. Let me use this one. CV over length. We can have modulation swinging all the way into wavetable mode. So you get little bursts of like steady tone in amongst granular makeup. Before I really dig into the onset analysis and detection, I want to jump over and show the default behavior of the mod CV. So this is the second bottom jack on the expander. This is a bipolar CV input, and the way that it functions is there are two parameters that can be controlled from 0 volts to 5 volts, and inversely from 0 volts to negative 5 volts. So the way I've got this set up, I've got, I think just off out of shot, there's a vinca here. I'm using the bias from the top output. That's going into the data, and that's showing on the red line here, and then out of that into mod CV. So as I go from 0 to positive 5 volts, what that's going to do is going to steadily draw in the stereo placement of grains. So at the moment, by default, they are falling hard left, hard right, and alternating with coin toss logic. As I increase this, you should hear, if you're listening in stereo, of course, it will be morphing it down to a dual mono. You can actually see that on the scope here as well. If I increase the intensity, you can see the center XY. There's a lot of placement across 2 dimensions. As I sum it down to mono, that changes into a straight diagonal. So next, if I go the opposite direction, go from 0 volts down to -5, it adds in a degree of randomization across the stereo field. So if I max it out, go to full -5 volts, it means that every grain that fires is going to get a random placement across the stereo field between left and right. So this is no longer just hard panned left, right. We have a true equal power panning stereo image placement of the grains. So between these two CV polarities, as long as you've got a bipolar control source that you can use, a manual CV, like from the top channel of the Vinca, then you can quite specifically place the spread of the grains within a stereo field. So one trick, if I change from being the manual CV, if I take that from the sample and hold signal, so this is now rectified, unipolar positive, so it's going from 0 volts up to 5 volts. So this is effectively giving me random spread over the grains. The same as if I had the CV fully negative, but this way I've got a bit more manual control over how far I might want to draw it out from hard panned. Okay, now we're on to the Onset jack. So this is a parallel audio input that is it's optimized for doing audio analysis on the signal seen at it. So we never actually hear what this input hears. It's all just done as a analysis for self control over the capture button. So what I'll do, I'm going to bring up the input level so we can hear from the microphone. I'll set it so that we can get a mix of wet and dry, mostly wet, so anything that does get captured will start to record in. And I'm going to bring up the sense control and then just snap my fingers or whistle a tone and introduce other various elements of audio, and that should automatically start capturing. The plus sign, when that's lit, it means that it's essentially armed and listening for some sort of content to trigger it. The duration that it will stay off while it's capturing is determined by the hold control. So it's almost like a noise gate, hold parameter on the noise gate. So let's give this a go. So you can see every time I snap my fingers, or even if it turns yellow and it's listening for my speech. So this time I'm using the same technique but with a patched example. So there's a few things going on. The main audio we're hearing is coming from the lower wavefold output of the CSL. CV to that is being quantized through the harmony. With a minor triad, the source is coming from this sample and hold. So if I bring up the sense input, I did it gently enough that there wasn't enough of a higher frequency spike in content for it to start triggering capture. For creating that, I have the top voice of the CSL mixing in with the main audio. So every time I strike this decay envelope, that's going to be essentially pinging the wave folder. So that impulse of a higher note should be enough for the sensor to pick up on it and then start capturing. So let's give it a go. So now I can start building up layers of captured content. So every time I fire the envelope, I can re-trigger recording whenever the plus sign is lit, showing that it's armed. The duration you can dial in, of course, for how long it's going to hold and ignore external audio. So that way I can trigger more impulses into the audio that will be ignored until a certain point. So this entire method of sampling for granular playback is quite different from what you see as maybe the traditional ring buffer, where it's constantly recording, and that kind of implies that you would use a fixed distance of the playhead following. So it kind of leads it to being a delay, whereas this sort of more real-time focused for any audio that's coming in, it's the content that's actually being played into the module that will trigger what gets captured. Okay, so next there are a few features I want to cover, but I'll keep from doing full extensive patch examples because this video might never end otherwise. So what we've not looked at yet is the trigger output jack. So you can see by default this is blinking away every time a new grain fires. If I set it to being a ramp envelope and always forward, it's a bit clearer visibly that's going on. So this can be used as a burst generator, external clock for various sources. There's some interesting examples where I could use a random voltage from a sample and hold to control the scan position. The content of this buffer is again sampled from the CSL, just the wavefolded voice, and it just opens up and gets brighter timbre at different points in the buffer. So here I'm using the grains themselves to clock the sample and hold, which is giving random voltage to the scan position. So a way of sort of like feedback patching of the grains themselves determining the position in the buffer. This random CV, it could be put in various different locations. It could be set to length, so every time a new grain fires, it's going to give itself a new grain duration. Intensity, same idea. We might have just jammed it. Alternatively, this clock could be used for any any other clockable source. So off camera, I put this patch together, which is the cease ADSR envelope, just using a decay shape to pull down the cutoff of a 1047 filter, and there we go. So every grain strikes it, I've essentially made a percussive voice. So the more rapidly grains fire, the quicker the kick is going to keep striking. So all very straightforward. What we can do, we can actually define different configurations of the clock output jack and the behavior of the onset analysis detection. So the way to do that, if I hold shift and capture together, I then have these four positions I can set the layer pot to. So alpha is the default here, where we have clock or triggers generated by the grains firing from the internal intensity, and the onset detection when the synth is turned up, it will. Actually, we'll turn this up and put down. So if I do trigger capture by mistake, it's not going to destructively replace. So if synth is up and it detects something, it will automatically start capture. If I switch it to the beta setting, we can see I've now turned off the trigger outputs per grain. So the grains no longer clock the trigger output, but if I bring up the onset detection, you can see that any time a new onset occurs, the gate output, well, it becomes a gate output as opposed to trigger. So this is now defined by the hold level, or the hold duration, sorry. So however long that is, it will be the duration of the gate as soon as the onset has detected something. So if I send that to my clock, or my kick, we're only going to see it on the release because this is looking for. It should do now. So I can use external signals to clock units outside of the arbor, so that the onset detection can be isolated and used independently. Now, if I hold shift capture again, set it to gamma, we can see we now have trigger outputs again from the trigger output jack, and the onset plus has now turned to white. So what this has done, this is effectively the same as the alpha setting, but we've now disabled the control over capture from the onset detection. So the plus will go on and off depending on whether it receives some sort of stimulus to it, but it doesn't actually affect the capture. And we remain with our clock signal that could be clocking external signals. This is handy if you for example, have the sense pot in the ideal position for whatever the context is you're using for self-capture, but you want to mute it temporarily but don't want to lose that position. So because if you turn sense down, you're going to stop the automatic capture, but then again you'll need to find that sweet spot again. So if you hold shift and capture, you can quickly switch between it actually affecting the recording into the buffer, which can be handy. The last position, if I go to delta, it's kind of the last remaining option there. So the onset detection no longer controls capture, and we have no trigger outputs, but we have gates for the duration of the hold from the sense. So this is a way to completely isolate the behavior of the onset detection for external use. So again, if I patch this to then I could use any external audio to control anything else in the system. So next up, I'm going to give some examples of the Arbor's, I guess, alternate modes. It's alternate behaviors for the mod CV parameter that's on the expander. If you look at the back page on the printed quick start guide that comes in the box, there's a little table that shows some switch configurations for switching these global modes. So you'll see on the back PCB on the inside, there's a little graphic that displays it in the quick start. There are two slide switches, one labeled AB, the other one XY. The default position is A and X, which gives the default panning behavior that I demonstrated earlier using the mod CV. There are three additional configurations you can have. The lower left setting, which is B and X for the switches, it's a bit self-explanatory. So the mod CV becomes a CV control over the hold parameter. So it means that you can CV how long the hold duration will be during onset detection. Not a lot to show there. That's not already been shown by manually changing it. The top right is a reverb parameter that can be added in. So the thinking behind this mode, it does come with some caveats. So you do get reverb, which is great. And it's a nice, a very nice sounding reverb, but because it's quite a CPU intensive process to add into the mix, it drops the sample rate behavior of the arbor from the default 64 kilohertz, 32-bit, down to 48 kilohertz, and it limits the internal clocked intensity grain count to 20. So 20 internal, 20 external clocked, and you can get up to 40 grains simultaneously. And 48 kilohertz, that's still more than industry standard for better than CD quality. And bit depth wise, it's always going to be 32-bit floating point that the processor runs at. So let me capture in some sounds into the buffer, and I'll give some demonstrations of the results you can get from the reverb. I'll bring up the input, and I'm just going to capture some snaps and claps, and maybe strike the wine glass again. Here we go. Okay, that's quite a lot of nice percussive stuff. So we're listening in stereo, of course. So this is hard panned grain distribution between left and right. So the CV configuration is much the same as the panning as demonstrated earlier. I've got the bipolar manual control from the top of a Vinca going through the data, and it's showing on the red line, then output of that into mod CV. So positive direction, as I go from 0 volts up, that's going to increase the reverb wet-dry mix, but simultaneously it also affects various parameters in the reverb algorithm to take it all the way up to essentially a freezing reverb. Up a little bit, and it adds a little bit of ambience to the sound. What I'll do, I'll silence the grain playback, lower the intensity. I'm going to go fully dry and bring up the internal microphone, and then bring up the reverb. So you can hear a bit what the reverb tail can get like. This isn't even up at full 5 volts. If I push it all the way up, we essentially get a freezing reverb algorithm. I'll bring it all the way down, max it back up, turn the input up and then snap my fingers and we'll hear how that reverb tail sounds. Do that once more. I'll bring the input gain down a bit so we can start to hear the noise floor otherwise. So you can hear it's a stereo reverb algorithm, so the spectrum is spread between left and right. And when you have it fully maxed out, the freezing algorithm, there's feedback in there with a lot of filtering, so as it cascades it will soften over time and eventually should level out. Then if you want to reduce the time, just bring down the CV and you effectively reset it by pinging back to 0. So it means if you sequence that or control that with variable voltage, let's try, let's send in our sample and hold. So we have varying different amounts of reverb. Bring up the input again. There we go. So we get some auto dampening in the effect. Okay, so that's the positive CV mode where you can still hear the dry signal as it goes in. If I go negative, then it reduces the dry signal that is heard from the arbor. So if I'll put it fully counterclockwise here to -5 volts, and snap my fingers, we should hear just the wet reverberant sound, but none of the dry coming through the microphone. So I'll go back to our wet sound and bring back some of the buffer recording. Longer length and lower intensity. Less pitch deviation. There we go. So now if I play between going positive CV and negative CV, there's quite a difference between hearing the wet and dry mix with positive versus going negative, where you hear just the wet reverb sound. It creates space and ambience to the sound, but it's quite a different effect when it's just wet versus just dry. So I'm going to try again with the sample and hold CV. I'll set it to bipolar so that we'll get some movement below 0. Then we get lots of different bursts of space added into the mix. So because this mode lowers the sample rate and lowers the maximum grain count, it's a balancing act. You're losing some of the full features of the arbor, but adding in the inbuilt reverb. So this mode's very much designed for use cases where the arbor's in its own, in a smaller system, where you might not necessarily have a separate reverb module running alongside. Because there's lots of tricks you can use the arbor with, where you might use the top output and the lower output might go through an effects chain so that you're only running effects on every other grain. There's lots of interesting ways to play with it with external effects. If you're in a smaller setup, then reverb mode adds quite a lot of functionality and timbral quality to it. Just because I'm going to add in a wine glass. This next example is going to show the delay mode. That is the force setting that can be set for the mod CV. This is using the two rear switches in the A and Y configuration. So it's not dissimilar from the methodology of the reverb mode, where you've got 0 volts to 5 volts gives you one effect, and 0 volts to -5 gives another. So the way I've got this patched up, I've got a little plucky synth voice that I can manually trigger from the cease here. We're just listening to this mostly dry through the arbor. Now I'm going to strike that and increase the mod CV towards +5. So as you can hear, this is a feedback delay setting where delay time is controlled by the range from 0 to 5 volts. And it's a fixed amount of feedback where there's some filtering and attenuation, so it's not going to blow up. It's naturally just going to slowly decay down to nothing. So this delay is applied to everything at the output, regardless of whether it's a dry signal throughput or captured audio. I'll capture a couple of strikes in. If I stop that, if I turn this fully wet. So we can see in here the playback audio from the buffer. That's now having the same effect through the delay. Okay, so next up, I'll go back to dry here, so I can manually trigger. I'm going to go from 0 volts to -5, and what this is going to introduce is a much shorter delay time set of feedback delays. So these are this side is designed for generating like a Karplus-Strong type resonant effects. So whatever the audio is that is coming from the output, it's effectively the impulse that is striking this Karplus-Strong feedback delay. What I'll do, I'll remove that patch and I'm just going to capture in a little bit of external audio mute the delay just now. So just the classic clicks and claps. Okay, switch this to fully wet. Some direction difference. A little bit of pitch deviation. So there, I've just muted the intensity so you can hear whatever was just played is now being fed back through the delay. And this occurs for both Karplus and positive delay times. So I'm going to add in some random CV from sample and hold. It's going to be giving random bipolar levels with a little bit of slew on it. So we can hear elements of the delay coming in and out. As soon as I mute the intensity, we can hear these artifacts of the remnants of the audio that are then being processed by the delay. So far in this example, I've been using just a single mono output from the top jack. If I patch back into stereo, you can now hear the left channel is unaffected by the delay. Only the delay is applied to the lower jack. We'll go back to manual control. So patching in stereo or mono in this mode, you get very different results depending on how you configure the setup. So you can have a bit of a wet and dry mix, go into different effects after the arbor. But listening to it in just the mono signal, you can get a lot of interesting textural madness. So for these final examples, I've got a bit of a different setup going. This is largely the configuration I've been testing the arbor with during its development. So I've got a bit of a roundabout way. I've got my guitar running through various preamps, VCAs to get them up to the right up to modular level, and that signal is going into the Onset input, so I can do onset detection analysis for automatically triggering the capture, and then that's normalizing through to the input, etc., etc. So I've got a bit of a mix of wet and dry, not a lot of spray. The scan is fixed to the beginning, so every time I start capturing new content triggered via the onset detection, it will start playing back the grains immediately, essentially. So let me start off by bringing up sense And the way I'm going to build this up, I'm going to record a single chord tone per layer and build up the voicing from there, and then sort of add in more layers as I go. So let's start for the first chord tone in alpha. So you can hear the immediate note being played, and then a lot of the granular stuff taking over very quickly. Next chord tone in beta. It's an interesting way to get a sort of extended sustain over notes that don't naturally sustain themselves, like on an electric guitar. And final note. So now rolled the volume off on my input. So now when I scrub through the different buffers, changing the layer, I'm essentially polyphonically playing the chord that I outlined note by note. Increase the intensity a little bit. So what I'll add in, I'll take an LFO from an oct and patch that into the layer CV. So now this is automatically just going to be cycling through the different chord tones. So now once I start playing in more notes or improvising over this harmonic bed, onset detection is still on. So every time it sort of picks up on a new note that I play and starts capturing, it's going to start dubbing in on top, so layering on top new content to the buffers. But depending on what buffer I happen to catch at that time, it's going to sort of spread it across the different layers. So let's see what happens. Point, I could even experiment with adding in some of the internal pitch deviation. So to keep it tonal, I'm going to jump straight to octaves. So I'm patching this. I'll have a positive CV that I can switch in and out. This module here. So I'll patch that into the associated CV for the pitch deviation control. And I'm starting to get octaves above and below of whatever segment of audio it happens to land on. think I happen to be in the Arbor's reverb mode, so if I bring in control voltage into the mod CV, I'll start to get amounts of reverb added in. So it's an interesting way to play with various different external audio sources. So the final mode that I've got to show on the Arbor is what's referred to as follow mode, and this affects the scan parameter. So by default, the position that grains are played from the buffer is determined by the scan pot and CV and the spray control for it. But even that is determined by the starting point for where it's spraying from. So there's an additional mode that changes how the scan pot functions. To get into that, I hold Shift, Capture, and then you tap the extremities of either far left or far right rotation of the scan pot, and it toggles on and off this LED. So when it's on, this is the module in follow mode. And what follow mode means is whenever the Arbor's capturing, you can see the record head's moving, the playhead follows it at a particular ratio. So you determine the rate at which it follows by the scan pot. So the further you turn it up, the more time dilation is introduced, where it's going to really slowly creep behind. So you basically got a record head followed by playhead for effectively granular time stretching. So if you capture like an impulse that is recorded into the start of the buffer, you'll hear that immediately if you've got any of the dry signal in, and then the granular playback of that is going to be moving and following at a slower rate. The rate actually can potentially go faster than the record head as well, depending on where the scan is. So all the way down, and it's going to give negative speed essentially, which seems a little strange, but the way that the Arbor functions, where it's always going to be capturing from the beginning of the buffer, it means that if you're destructively replacing or overdubbing, there might be audio content remaining at the the later stages of the buffer. So there might be older content that, as soon as you trigger trigger capture, or it's triggered by the onset detection, for instance, then the playhead could rush ahead and it could scrub through pre-existing content. So you can end up with some interesting behavior from that. So a good way to demonstrate this is quite simply by triggering capture with onset with just clapping your hand. So you create some sort of impulse that then gets captured, triggers it, and then that impulse gets stretched out. So to do that, I'll bring the input level up, and I'll bring the sense up a bit, and then I'm going to clap, and we should hear that clap followed by a sort of granular stretch of the impulse. If I introduce some pitch deviation, you can hear it's already capturing my voice and processing it in real time, but at a slowed down factor. Let me I'll increase hold a bit, so this way I can speak and it's going to be capturing my voice. Testing. There we go. So anytime it is capturing audio, you can see the playhead is slowly following the record head. I'll take synth off so I can manually capture it. This way, as soon as I press capture, it's going to be picking up the audio. I'll increase the intensity and bring the length down. So now when it captures my voice, it should play back what I'm saying, but at a lower rate, sort of processed and stretched out.
Play back what I'm saying, but at a lower rate, sort of processed and So now when it captures my voice,
anytime you trigger the strike button, it will jump back to the start of the buffer. So this is getting confusing because I'm talking over myself now. But that could be triggered externally from an external source. So I could use an LFO for that. Here we go.
So now when it captures my voice, it should go back what I'm saying. So now
this way the speed is directly controlled from the scan pot.
It should play back. So now when it captures my voice, it should play back. So now when it captures my voice, it should play back.
So I'll clear that and I'll capture in some new, slightly more interesting impulses. Set it to follow quite slow, no spray, a bit of length, a bit of intensity. Back to the trusty wine glass. And what I can actually do, if I go back to the guitar, when I'm playing a chord, you can hear with the playhead following it slowly. So this can work nicely if I use a bit of dub so that I'm not completely removing the previous audio. effect. A bit more destructive overdubbing.